trying to show you all is real world examples. So this is a typical network security architecture of, say, a IT company, and or it can be even any kind of organization. Okay, but this is typically more where you have a IT kind of organization as well. So there are different components here. See, so here you have an internal firewall, VPN. So VPN is a virtual private network. I'll be talking about it in the upcoming slides. Okay. So to defend its internal network from illegal access and cyber threats, an organization installs a network security architecture that comprises of a firewall. So these are firewalls, intrusion detection and prevention systems, and also you have your other security tools like your antivirus servers within your network. You have web proxy server. This is also security tool. Okay, all these are the various uh, controls for a network security architecture. And besides this, also you may be having wireless network connectivity to your internal networks. So you can deploy Wi-Fi security controls as well. So that is also a part of the network security architecture. Okay, Wi-Fi, secure Wi-Fi. Okay, so more on firewalls. Okay, so yeah, here we have a firewall that is put. Okay, so basically, as it says, it's a wall. Okay, that's a wall that is protecting the external network, the public internet network, untrusted network. So this firewall is protecting uh, any hits or any unauthorized access from this environment into our trusted internal network. So the external network is called the internet network, while the internal network is called intranet network, internal. Okay. And then, yeah, in this diagram, we have something called as a DMZ or a demilitarized zone, right? So these are typically where you build a zone where there would be some kind of access from the outside internally. You can redirect into the DMZ zone, and also people from internal also access into the DMZ zone. So if you have some specific requirements where some resources have to be accessible for both from the intranet as well as from the internet, so you build something called as a DMZ zone. Okay, so network firewall are devices, okay, used to prevent private networks from unauthorized access. A firewall is a security solution for devices that are connected to a network that can either be in the form of a hardware as well as it can be a software. It monitors and controls all the incoming and outgoing traffic and the amount of data that is moving across the computers at a given time. The major purpose of a firewall is to protect the inner network by separating it from the outer network, which I just said. The inner network is okay. What is the disadvantage or what is the limiting factor of a firewall? It needs to be regularly patched. Okay, since it is uh, constantly being exposed for all these environments. So the firewall has to be you should be very cognizant of securing this device. So if you would have seen, right, in your day to day, like on your phones and even on your laptops, you'd be getting messages saying that there's a new version of a security patch, so that needs to be applied. So this is more so on firewalls because it's taking a lot of it's constantly being attacked, right? It's a first layer of defense, right? Right. Again, yeah. So this is elaborating more on firewalls, right? Firewalls protect against external and internal threats, and centralized. Firewalls can have a centralized policy enforcement. So if you have multiple firewalls, so you can have a centralized policy and deploy, similar kind of rules across your organization. It protects against malwares, and you can set up access control to allow only certain kind of traffic, right? So I mean, these are key pointers of a firewall. What you need to be careful about when you're designing firewall is, you should design and configure it more carefully. Okay. Because if you misconfigure it, or you make a rule that you miss out something, then it's extremely dangerous. You're completely exposing your internal network outside. So it has to be done by an expert, somebody who's a thorough understanding of what he's doing. Okay. Next is a firewall. It cannot protect traffic that does not cross it. Okay. So suppose if there's some data transfer that is happening, internally within the network, right? So if there's no firewall between that, you cannot detect or do anything about it. Okay. Firewalls provide little protections from insider threats. Okay. And its failure can lead to a network failure. Okay. So suppose your organization, say you're dependent on a single firewall, and that firewall goes down, and your complete network would be down. Uh, uh, Firewalls, as I said, it has to be frequently patched, so that all the if there are any 0-day new vulnerabilities that occur, so that it should not be exploited, right? So that is why it has to be frequently patched. So this slide talks about the different type of firewalls. Okay, so firewalls have evolved over a time, and currently, we the firewalls, we refer to them as the next generation firewalls. So initially, when these firewalls came, it used to be function as a packet filtering firewall. Okay, so it monitors all the incoming and outgoing packets, and based on some simple rules, if there is rule for, if a source and destination information with the internet protocols are set up with the ports, and if those requirements are met, it is to allow the traffic. Others, it used to block, right? So these packet filtering firewalls are also called static firewalls. Okay, these are the first generation firewalls. So then, it further developed, and then we have a newer type of firewall called stateful inspection. So in this type, packet filtering is done to control how the data packets move through the firewall. Okay, so it is also called as a dynamic packet filtering firewall. They inspect if the packet belongs to a particular session or not, and it only permits communication if the session is perfectly established between the two endpoints, else it will block the communication. Okay. So an example to this is, there's a request coming from outside, coming inside. Okay. So what a stateful inspection firewall will do is that for the traffic that is coming inside, it will check whether there is a corresponding request that is going outside. Okay, so if these two are in place, only then it will allow. So it used to do this additional checks. Okay. The next is the proxy or application level firewall. Okay, so these firewalls, they examine the at the packet level, like at the application level, the HTTP application level or the FTP level, right? These are different applications. So at that level, it will check the packets to look for any malicious or suspicious content, and only if it is safe will it allow the package to come through, else it gets blocked. Okay, it intercepts all the traffic and it repackages it before it's sent out. And finally, now we have the next generation firewall, which is also called as intelligent firewall. They perform the tasks from all the other firewalls which we have here. Okay, and it also has additional features of application awareness and controls, integrated intrusion prevention, and delivered threat intelligence. Okay, cloud delivered threat intelligence. So these firewalls have intelligence of learning or getting inputs externally. That these are, if there is some kind of threat that is going out in the internet, so the firewall provider, he will send this information to the firewall and say that, okay, if this kind of threat traffic comes in, it should be blocked. So that's how the next generation firewalls work. Example of a next generation firewall is Palo Alto is one of it's a next generation firewall. Okay. So this is again we are still on the firewall topic, and here we are talking about a typical firewall setup where there are two firewalls that have been set up here. So this is a very typical industry standard where there will be an internal firewall for the internal traffic. Okay. So like here, this is the internal firewall. Okay. So this firewall is protecting these servers or these internal servers from internal users. Okay. And then we have the public firewall. So this firewall protects the internal network from external. So that is why they recommend to have this kind of internal firewall. And maybe you may have some different types of groups who are accessing these servers. So you can put them in separate say buckets, okay, to access these resources. Okay, this is an example of two-tiered firewall architecture. And here we have a typical how the firewall rules look like on a firewall device. Okay, so this is an example of a Cisco PIX firewall, and these are the rules. Okay, so here we have the source IP address, destination IP address. What is the protocols? What are the ports that are allowed? Okay, these are all port numbers. So this is typically how a firewall rule looks like. And what you're supposed to do with this with these packets. So yeah, these are saying it's accept or whether you have to drop. Okay, all that. And then down below is a checkpoint firewall. These are different firewall companies. This is how it looks like. Okay, so checkpoint is an advanced threat prevention kind of firewall, while Cisco PIX is a stateful hardware-based firewall. Okay. Okay. Going ahead. So within the network architecture, we have another tool which is called intrusion prevention or detection tools. Okay. So intrusion prevention systems, okay, is a network security application that monitors the network for activities of malicious, it looks out for malicious activities. The major function of an intrusion prevention system is to identify and collect the information and report it in an attempt to block or stop it. Okay, so it monitors the suspicious activities and then protect it. Uh, so workings of an intrusion detection system. So it monitors the traffic on a network and detects any suspicious activity. It analyzes the data flowing to the network, looking for patterns or signs of abnormal behavior. The intrusion detection system compares the network activity to a set of predefined rules and patterns. And anything which is an indicator of an attack or intrusion, it then goes and acts on it. Whether whether you want to further investigate it or block it or what, it gives you all that information. If the IDS detects something that matches one of the rules, it sends an alert to the system administrator. Then the administrator can investigate the alert and take action to prevent further damage. The IDS also looks for malicious transactions, and it checks activity and policy violations. Okay. The intrusion prevention system also it also helps in blocking of known software security exploits. Okay, so these are against software exploits, and the intrusion detection systems are typically placed at the network boundaries. So typically, it sits on top of a Palo Alto firewall on a in a next gen firewall. Okay, yeah. So that's what it's saying. Yeah, combination of IDS and a firewall provides good perimeter security. Okay. Uh, you also have intrusion prevention, which is put on the on hosts. Okay, so it is called as host-based intrusion detection systems. So they like you have a server and you want to keep continuously monitoring on it all the traffic that is coming in and going out. You're very very focused on protecting say a one server, so you can just put a host intrusion detection on the server itself, so it will check whatever traffic that is going into that particular server. And then you have something called as network intrusion detection systems. So it's set up at different points within the network. So basically, intrusion detection is basically a sniffer with the capability to detect traffic patterns through an attack signature. So that's what it does. It compares. That's a function of a IDS IPS. So more on IDS. Okay, so an intrusion detection system, it monitors the systems and analyzes the traffic for possible hostile attacks. Okay, this is the so just make a note of these the differences here. So this is intrusion detection system, while here it is prevents. So here, so in layman terms, a detection system it only notifies when there is some malified or unintended or unsecured traffic. Okay, it detects. It does not actually stop it, but a prevention system, it will go ahead and stop it itself. So that is the main difference between the two. Okay. So the intrusion prevention systems can take actions such as sending an alarm, dropping a detected malicious packet, resetting a connection, or blocking. So all this you can do with the intrusion prevention. So these are the various types of intrusion prevention detections. So one is based on detections. So based on profiles or some kind of anomaly based detection. So it monitors the network against establish baseline, and if it finds something, then it alerts the administrator, and then uh, you can block or whatever, take action. The negative for this kind of IDS, it is prone to high number of false positives. So it may be genuine traffic also, it can block it because it's just purely based on some anomaly, some something it thinks that it's not legitimate, but it may be for that matter, right? Okay, then there's another which is signature based. Okay, so signature based IDS will monitor packets on the network and compare it against a database signature. And if those match, then it will call it as a malicious. Okay, so it's similar to how an antivirus uh, device operates. Okay, and signatures are set patterns pertaining to a typical intrusion. Then based on deployment, so in the last slide I spoke about host-based intrusion detection systems. So see, as I said, it provides security to an individual device within the network. Okay, the agent gets deployed on an operating system, and it is to monitor and analyze activity on the host. Okay, and it needs to be deployed on all the hosts, and it is okay, and this is primarily used for insider threats. And then you have network intrusion detection systems. So this is put at strategic points in the network. Okay, we've already spoken about it. So these are the different types of IDS, IPS. Okay, so more on network intrusion detection. Uh, so so IDS and IPS, they work together to provide a security solution. The IDS or the detection system, it captures packets in real time, processes it, and then responds to a threat. But it works on a copy of the data. Okay. So whatever data that is flowing, it takes a copy and then it checks it. It does not work on the actual data. So that is the difference between an IDS and IPS. So in the process of detecting malicious traffic, an IDS can allow some malicious traffic to pass before the IDS can respond or protect the network. Okay, so it's like a post de facto. So it takes a copy, then it processes that copy, and then it detects whether the traffic is malicious or not, and then it acts, right? So in the meanwhile, some amount of traffic would have already gone by. Okay. So this is what is called as promiscuous mode, because it is not working on the actual data. So it is called the promiscuous mode. Okay, and while the IPS works in inline, okay, so it works on the data stream to provide protection from malicious attack in real time, and this is called inline mode. So here we have, this is called the inline mode. So unlike in IDS, IPS does not allow packets to enter a trusted side of the network, and it blocks the attack which would normally pass through to a traditional firewall. Okay, so this is the differences between IDS, IPS. So more on IDS, IPS. Uh, so uh, so this is the classification is more on where the sensors are placed. So sensors which are placed outside. Okay, so outside means maybe outside the firewall. Okay, so it checks all traffic that is destined to your network. It has a high possibility of raising false positives, and it does not detect internal attacks. Okay, When the sensor is placed inside, it checks only traffic that is permitted by the firewall, and it has a lower probability of false alarms and requires immediate responses to alarm. Okay. So the IPS sensors are placed before the public firewall, and it requires to check all the traffic. This can cause raising false positives. So this is the most optimal method of placing your intrusion detection system behind the firewall. Okay. So in case it is faced beyond the firewall, it will defend against noise from the internet or attacks such as port scans and network mappers. Anyway, these are different places where you can how you deploy your IDS IPS. Uh, I'm not sure. We are kind of running behind. So Vidya, maybe we can just take a 2-3 minute break, and then we can just quickly continue. Maybe we can adjust about 15-20 minutes.
Okay, sir. So can we go ahead with the poll, or we have 2 more?